Hello, class. Welcome back. Interesting times, but like I said, it's the best thing we can do here is move forward and try the best we can in terms of finishing out and get as far as we can to help out for next year. So we're looking at trying to finish up chapter 3, where we kind of got stuck just before we had to isolate ourselves here. So this is basically a review for chapter 3 in terms of what we did, and also to kind of wrap up what we didn't quite get to, which was not much left. So what you need to do here is finish up with 3.6H, and then I will be posting the practice exam of chapter 3 at some point in time. But I want you to be able to finish up on this, and I'll send out a email in terms of clarifying dates and times and all that. So let's just go ahead and get started and do a little review, see what you can remember. So first off, let's go multiplying two complex numbers. So multiply two complex numbers. That's a number there. All right, so let's say if we have 2 plus 3i and 5 minus 4i. Now remember, there's going to be more to this once you get the trig. When you multiply two complex numbers, you are actually adding angles together. So you're taking one component to another component. But like I said, we're just doing the math for now, getting you ready to take the next step next year. So you have 2 plus 3i, 5 minus 4i. So you have 10, 15i, negative 8i, negative 12i squared. And remember, anytime you have an I squared, it's negative 1, or square root of negative 1, it's I. But we're doing this one here. So this is actually a positive 12. And therefore, you want to keep track of your x components. So you have 10 and 12, or 22. And then your y components, which is your i's right here, would be plus 7i. And that's all we're doing for now. Okay, we'll talk about more on that, but remember we can also write these as a component of 22, 7 of that. Okay, and remember to graph that out. Obviously it's a big number here. You go over 22 and 7, and basically you have that. And obviously there's an angle here that we'll talk about next year in trig. Okay, adding these. So let's say we have 2 plus 3i plus 5 minus 4i. Okay, so basically you just add the x components. So here's my x components, here's my y components. So you just add x's and x's and y's and y's. So you have 7 minus 1i. And again, this can be written as a ordered pair, 7 comma negative 1i, like that. And if you want to graph it out, you have out 7 and negative 1. So therefore, that would be that component of 7 comma negative 1i. Okay. Again, not putting any context to this yet. We're just doing the math this year. But if you have two components, let's say let's say this is your A, let's say this person is pulling, let's say an object here, let's say a sled, and that is 2 comma 3i. And you have another person over here pulling 5 comma negative 4i. Basically what you have here, let's change color. Okay, is a parallelogram, and the result of this is this diagonal measure here. So it's the result of two people, that's B, and A, pulling on an object or pushing an object, or if you're kicking a soccer ball, all that, this is the result of those two components. Again, we're just doing the math. The application comes much later. Okay, let's do a subtraction one here. So let's take the same thing here and let's say 2 plus 3i, and let's subtract them. And basically what that does is, basically, if you come back to this problem up here, it reverses this the other direction. So this value, or this component, is changed to -5 plus 4i. It reverses it by 180 degrees. Okay, so now you change it. Now go back and now add it. You have -3 plus 7i. Okay, again, remember this can applies to -3, 7i by graphing. Okay, so quick review on complex numbers, that part. Next part, graphing with focus and directrix. So graph with focus, directrix, and vertex. And remember, that's vertex form in terms of putting the equation into a direct setup. All right, so let's do an example here. So if I have, let's say, the focus of 4, 0, and a directrix of y equals -6. So, not sure why that popped up. Oops. How do we get rid of that? Okay. You graph out. Oh, go away. 1, 2, 3, 4, and this is y equals -6. So 1, 2, 3, 4, 5, -6. So therefore, this point here, if this is 4, 0, then this would be 4, -6. So now remember, your focus, or excuse me, your vertex is right in the middle. So halfway between 0 and -6, that vertex would be 4, -3. And it has to go around your focus. Okay, so that would mean that I have my vertex, which is 4, -3. Now you do need your scalar or your slope. So if you know your distance between here to here, between your vertex and focus, or your vertex and directrix, it's equal to the equation 1/4p. So in this case, the distance is 3 equals 1/4p, and therefore p is 1/12. And it would be a positive because it's going around it. So if it's going down, it'd be negative. So therefore, in vertex form, my function f of x would be 1/12, and then using my vertex, x minus 4 squared minus 3. And there you have it. Okay, let's do a different combination here. Let's say we have a vertex of 4, 2, and let's say just another point, and that is 6, 8. Now, I highly suggest you gotta do a quick sketch of this, so let's do that. So you have 4, 2, okay, and the point 6, 8, like I said, we're just gotta sketch it out. Is there. The only reason I know that is just so that it's going to be positive and not negative. So let's put the point underneath each other, 6, 8. So if we look at this, my delta y for my slope would be 6. My delta x would be 2. Now your slope is delta y or delta x. But remember, this is our parent graph is x squared. So we got to square it. So my slope would be 6 over 2 squared over 6 fourths to 3 halves. And it would be positive because we determined that before we started. So now using my vertex and my scalar, I have y equals 3 halves x minus 4 squared plus 2. And there I have it. Okay. While we're on there, let's say if we just want to find the distance between 2 points. So distance between, let's say 4, 2 and 6, 8. So again, if you do your delta y is 6, your delta x is 2. Remember, your distance is Pythagorean theorem, c squared equals a squared plus b squared. In this case, we just say d squared because it's a distance. So what we have here is 2 squared plus 6 squared. So we have 4 plus 36 is 40, and d is root 40. Oops, 40. Look to break that down if you can, like 4 and 10. And what we have here is 2 root 10 is our distance. Okay. All right. What else to review here? Let's look at, let's say, two functions. Let's say y equals x squared minus 4x plus 4. And say y equals negative x squared plus 4x minus 2. Now again, I could just say f of x, and I could say this is g of x. Either way, set them equal to each other. So you have x squared minus 4x plus 4 equals negative x squared plus 4x minus 2. You have to set it everything to one side here. Take a look at what you have. So plus x squared minus 4x, and let me see here. I'll just go ahead and put everything on one side first. So all that cancels, so I have it set equals 0. I have 2x squared minus 8x plus 6. So what I'm going to do here is I'm going to complete the square and solve it that way. Now I could do also box and x method. I could do that approach. So let's divide by 2. So you have x squared minus 4x plus 3 equals 0. And if we do, say, that x thing here, I think that would work for the shortcut. Plus 3x squared minus 4x. So factors that work here. You have 4 and 1. Or excuse me, 3 and 1. So if we make them both negative and put an x here, multiply these two together, that gives you positive 3x squared, and when you add them, you get this. Okay, so put everything into a box. Okay, so I have x squared and plus 3. So again, that's these two values. Okay. Now using these two values, minus 3x minus 1x. Now factor out. So here, take an x out, be minus 1. Here, minus 3. So my factors are x minus 1, x minus 3 equal to 0. And therefore you have x equals 1 and 3. Now, what we can't forget, though, that we are looking for where they are intersecting. So I need to come back and borrow one of the equations. I'm going to take y equals x squared minus 4x plus 4. And I'm going to plug in, and again, this could be f of x. I'm going to plug in f of 1. So it'd be 1 minus 4 plus 4. So that would be 1. So that would be 1, 1 where they intersect. If I put in, let's say f of 3, that'd be 9 minus 12 plus 4. So we got here 13, 1. So therefore it'd be 3, 1. Okay. All right. Let's do one more last review, and then we'll do inequality. So let's say if we have f of x equals 3x squared plus 6x minus 12, and we want to put this in vertex form. Okay, so remember how to do this. Cancel this off, set equal to 0. We do have to divide by 3 because you have to have a 1 here. So I have x squared plus 2x minus 4 equals 0. Next step, you gotta move this to over. So you have x squared plus 2x plus blank equals 4 plus blank. Okay, so here's the number there. Take half that. So two things we gotta have is 1, and we got squared equals 1. Okay, so I'm going to use this value first, so that's 1 and 1. And this then would be x plus, so it'd be x plus 1 squared equals 5. And we're putting this into vertex form. So I got to put the scalar back in, and remember my scalar was 3, so we got to multiply by 3 and 3. So I have 3x plus 1 squared equals 15. Then move it back over, and let's go ahead and we have f of x equals 3x plus 1 squared minus 15. So remember what we can get from this is the ability to graph. We have my parent graph y equals x squared, and 2, my vertex is -1, -15, and remember my scalar is 3. Okay. All right, so to wrap this up, basically, let's take this function here. Instead of an equality, let's change it to, let's say, less than 3x plus 1 squared minus 15. So what does that do to my parent graph of x squared? It actually just creates a dashed line. And since it's less than, that would mean that I'm going to shade below that graph. That's all it changes. So what's some other combinations here? So let's say we have, say, f of x. Let's go greater than or equal to 3x plus 1 squared minus 15. So therefore, on my parent graph, y equals x squared. So now it's going to be a solid line. And the way I'm going to shade, since it's greater, maybe shaded above. And that's the only thing changing. Let's do just a different one. Let's do an absolute value one. Let's say we have h of x is greater than negative x minus 1 squared plus 2. So let's go through the steps here. Parent graph, y equals absolute value of x. And this would be a dashed line. Okay. And for right now, before I do anything else, let's change that to, that would be greater, it would be above it. Okay, so step 2, I have a negative on the outside of my function, which means it's going to be a dash below. But my shading is still above it. Okay, so then my vertex 1, 2, and therefore there's my graph. There's where it's located. So let's go ahead and do it. So we have 1, 2, dash line. What's my scalar? Scalar is 1, so over 1 down 1. So dash line. And then let's go ahead and shade. And that's it. That's all you gotta do. I'll do one more example here and we'll call it quits. All right, so let's say we have h of x equals, less than -2 x plus 1 minus 3. So 1, my parent graph, absolute value of x. So this would be a dashed line because there's no equal sign there. Okay, shading purposes, it is less than, so it's going to be down below. Okay, so now 2, my vertex, actually, there's a negative on the outside. I should probably say h, not f. So that means it's now flipped. But my shading still is below. Yeah. Now my vertex is -1, -3. And don't forget my scalar is of 2. All right, so there's what my graph looks like. Scalar 2. So we're graphing this out. -1, -3. Now go over 1 down 2. Over 1 down 2. Dashed. And still shade. And there it is. That's the last little bit that we had to do. Not too much extra. Okay. So anyway, so remember to finish out worksheet 3.6H, and I'll give you instructions on how I'm going to do the practice test later.